Are you looking for a data type that's more formal than maps? Elixir Structs define the data shape and can enforce initialization. Remote control car is a perfect practical challenge to solidify your understanding of defining, updating, and pattern matching against named data structures. Howdy, I'm Kevin, and in these videos I pair my development experience with AI tools to help present comprehensive Exorcism solutions. I prompt Copilot to add documentation and provide a starting solution. We'll evaluate Copilot's code and explore alternative approaches and surrounding ideas. I'll include segments of NotebookLM videos or quizzes to introduce concepts. Here's how NotebookLM introduces structs.
So let's start with that big question. How do you actually build predictable data structures? You know, the kind you can trust, without having to litter your code with all these checks and guards just in case something goes wrong. That's really the puzzle we're here to solve today.
And the answer in Elixir is just so elegant. It's structs. Now, you might think they're just maps with a fancy name, but they are so much more. Think of them as a blueprint for your data. They give you guarantees before your code even runs, and that gives us a super solid foundation to build on. Let's see exactly how that works.
Think of an Elixir struct as a sealed, labeled, and standardized component from a factory. It has a defined shape, guaranteed slots for specific parts, and if you want to update it, you don't modify the component itself. You swap it out for a brand new, updated version that reflects the new state. This is how functional programming manages state change safely.
All right, enough theory. Let's get our hands dirty and actually start building our remote control car. First things first, we need a new function that just spits out a standard car for us. Full battery, zero distance driven. The challenge here is making sure that this default state is 100% consistent every single time, with absolutely no room for error. So here's the classic Elixir way to do this. We use defstruct for any defaults that are static, that never change, like our starting battery. But for values that might be set dynamically, like the nickname, we handle that inside the new function itself. It's a really clean way to separate the data's blueprint from its starting state.
Let's take a look at how Copilot defined our remote control car structure. Here's where we're defining the structure. So we're in the module remote control car. We've defined a structure. It's got three properties: nickname, battery percentage, and distance driven. Nickname does not have an initial value, while battery percentage and distance driven do. The line above that in force keys says that when you're creating an instance of this structure, you must provide a value for nickname. So in the new function here, we're creating a new structure of type remote control car, and we're providing a nickname of none. The one better practice I would say here is, instead of declaring the name of the structure in here, use the macro module, and then that way if you ever change the name of the file, the module remote control car, then you don't have any maintenance here. This is a compile time macro that will replace the underscore module with remote control car.
Okay, we've got our default car, but what if we want to add a custom nickname?
The Elixir way to do this? A second new function that just takes the nickname. It's a classic pattern.
I want to talk about a little bit of a difference in declaration here. You might have been tempted to say, I'm going to define my struct with a default value of none for the nickname. And this is not quite the same as what this version is. This top version says nickname needs to be provided and it will not be nil. This bottom version says you don't have to provide me a nickname, and if you don't, I'll use none. But if you do, I'll use it even if it is nil. And that's not what we want. So the first version, the version we had a moment ago, is correct. So to define a new one with a nickname, we're going to have a separate function that takes in the nickname. We're going to make sure it's a string, and then we're going to create a remote control car with that nickname. Hey, let me know in the comments whether you were inclined to have a single function with a default value instead of two. Which one is preferred? Do you prefer? Let me know in the comments. Future me here. Turns out that Exorcism really wanted us to use a version of the new function with a default value rather than two separate functions.
Great, our car is created. Now how do we actually show its distance?
We'll use pattern matching on the struct itself. This is huge. It makes sure we only get car data.
Display distance has a couple of really cool things going here for pattern matching. So we have display distance. What we're saying here is that we want a structure of this type, remote control car, and we want to pattern match specifically the property distance driven in meters and pattern match the value in meters. And then inside the function, we can just refer to meters, whatever the value it was, and put it into the string.
Okay, distance was easy. Displaying the battery, though, that brings up a new problem for us to solve.
See, if the battery is at 0, we need to show a special message, and we want to avoid messy if statements. And here's the beautiful Elixir solution. Separate function heads for each state. So clean.
Display battery uses pattern matching again with different function heads for different states on the battery percentage. The first line here says, given a remote control car, when the battery percentage is 0, display battery empty. The second one says, for any other battery percentage, let's capture that as P, we're going to display the battery at P. I want to take a moment and talk about what this module prefix does. If we remove them, then basically what we're saying here is display battery will match any other structure or a plain map, so long as they have a battery percentage property. By including the module in our pattern match, we're saying, no, it can only be a remote control car that we're going to match against for the function to work.
This pattern is a game changer. Now let's get this car moving and apply it to the drive function. Driving the car is pretty straightforward. Add 20 meters to the distance and drop the battery by 1%.
But remember, this is Elixir. We don't change the car. The drive function returns a brand new car struct.
Copilot's code for drive is a little bit inconsistent. Here what we're saying is in the first version of drive, we pattern match battery percentage is 0, and under that circumstance, we just want to return the car. Then down here in the other version, where now we have a battery percentage that's something other than 0, it doesn't pattern match any of the values in the function head and refers to instead the properties by car and the dot notation into the properties. A more consistent approach to this would have been to pattern match the battery percentage and the distance driven in the function head and then use them straight away in the body of the function.
And just like that, you've built it. So let's quickly recap why this approach is so powerful.
So, use structs for known data, multiple function heads for different states, and pattern match everywhere.
So putting it all together, you might have a function like drive until empty. It takes the car, it calls drive on the car, displays the distance traveled and battery remaining, and calls itself. And when it finally gets to battery percentage of 0, it just returns the car and the recursion stops. So we see that the meters is going up, the battery is going down, and when the meters is 2000, the battery is empty. And then here we see the actual struct, which is our car. We didn't have a nickname because I just used the new battery percentage is 0, driven in meters is 2000. Like and subscribe if you found the structure of this lesson helpful. It's the key pattern for how you help define new content. Drive into the playlist to build your expertise one powerful function at a time. See you there.